Okay, so here we're looking at problem 1 on homework 6. So this problem involves finding antiderivatives of several functions. So part A, we have this function here. So if we want to find the antiderivative of the function, we can apply the rules that we've discussed in class. So recall that we have the power rule, which says that the antiderivative of x to the power p is 1 over p plus 1 x to the power p plus 1. So that means for a term like x cubed, we can use the anti-power rule to get, with p equals 3, to get the antiderivative of that term is 1/4 x to the 4th. Now remember, when you take the derivative of an exponential function, you get log of the base, in this case log of 3, times the original function, 3 to the x. So when we take the antiderivative, we have to divide by that constant, and then have 3 to the power x. Then the last term, x is now in the base again, so this is another power function. So again, we can use the anti-power rule. So we'll get 4 over negative e plus 1, x to the negative e plus 1. And then, of course, we can always add a constant to the end of our antiderivative. So that would be the answer for part A. Basically, it's an application of the anti-power rule and the antiderivative rule for exponential functions. Okay, so now part B, we have the function f of x equals 1 over 1 minus x. So we know the antiderivative of 1 divided by x is natural log of absolute value of x. This looks quite close to 1 divided by x, so we expect something with natural log might work. So the thing to notice is that the derivative of natural log 1 minus x is equal to negative 1 over 1 minus x. So it looks quite close to what we wanted. So we have that the antiderivative of 1 over 1 minus x is going to be equal to natural log absolute value 1 minus x. But then when we took the derivative up here, we got a minus sign out front. We don't want that minus sign in our original function, so we have to put a minus sign here to counteract that. And then again, we have a plus c. So the last part of this problem, we have f of x equals the derivative of some complicated function, x cosine of x plus x to the power x minus log of x to the power 4. So this looks pretty nasty. But the important thing to notice is that it's not just this function here, it's the derivative of this function. So if we want to find an antiderivative, it's actually fairly straightforward because derivatives and antiderivatives are inverse processes, so the antiderivative of the derivative gives you back the original function up to an unknown constant. So because d by dx and anti-differentiation are inverse operations, we have that the antiderivative of this derivative I think I need one more, is going to be equal to just this function that was inside here, x cosine of x plus x to the power x minus ln of x to the power 4. And then we again have to add on a constant because when we take the derivative of the constant term is 0. So we do have to include that in our antiderivative. Okay, so that's all the parts for problem 1.